How does the gradient optimize backpropagation in neural networks? Imagine trying to find the quickest way down a mountain in foggy weather. You need a guide that tells you which way slopes downward most steeply. That's what the gradient does in neural networks. It acts as a directional sign, showing us how to change each part of the network to make it better. When training a neural network, we want the predictions to match the actual data as closely as possible. To do that, we need to understand how each weight and bias affects the error. This is where the gradient comes in. It measures how sensitive the error is to small changes in each parameter. The process starts with the neural network receiving some input data. The data moves through the network, layer by layer, with each layer applying weights, biases, and activation functions to transform the data into a prediction. Once the network makes a prediction, it compares that to the real answer using a loss function. This loss function calculates the difference or error. The bigger the error, the more the network needs to learn. Next, the backpropagation process kicks in. It uses calculus, specifically the chain rule, to work backwards from the output layer to the input layer. This helps compute the gradient of the loss with respect to each weight and bias. Think of it like tracing the steps of a recipe to see how each ingredient influences the final taste. The gradient tells us how much each parameter needs to change to reduce the error. Once we have these gradients, we use an optimization algorithm called gradient descent. It updates each weight and bias by moving them a small step in the direction that lowers the error. The size of this step is controlled by a learning rate, which is like the speed at which we adjust. If the learning rate is too high, we might overshoot the best values. If it's too low, learning will be slow. This cycle repeats many times over many data examples and training rounds called epochs. With each pass, the network's parameters get closer to their optimal values, making the predictions more accurate. The gradient is essential because it provides the precise information needed to make these adjustments efficiently. Without it, the network wouldn't know how to improve. This mechanism is the backbone of deep learning and specialized artificial intelligence. It allows models like ChatGPT, DALL-E, and Midjourney to learn from data, get better at generating text and images, and become more useful over time. The gradient guides the network step by step, helping it learn complex patterns and relationships in data. Understanding how the gradient works in backpropagation also raises questions about ethics. It's important to ensure that training data is fair and unbiased, so the models don't learn harmful stereotypes. Transparency about how these adjustments happen helps build trust in AI systems. In short, the gradient acts as a compass for neural networks. It shows exactly how to tweak each parameter to make the model smarter and more accurate. This continuous guidance is what makes modern AI systems capable of learning from data and improving on their own.